Project 216. Have you ever wondered about the environmental impact of steam methane reforming, or SMR, in ammonia-urea production? It's a question worth pondering, especially when you consider the significant contribution these processes make to greenhouse gas emissions. We see a method that has served us well for decades, but is now unfortunately part of the problem. The process begins with natural gas and steam, then ends with ammonia and urea. But along the way, it leaves a carbon footprint that's hard to ignore. The gap load between the ammonia and urea plant results in CO2 emissions, accounting for a whopping 15 to 20% of the total output. That's a sizable chunk of greenhouse gases, especially when you consider the sheer volume of ammonia and urea produced worldwide. With the increasing global population and the rising demand for fertilizers, a more sustainable solution is needed. And that's where we come in. Our proposed novel solution is to integrate methane pyrolysis into conventional SMR-Ammonia-Urea process plants. So what is methane pyrolysis? It's a thermochemical process that transforms methane into hydrogen and solid carbon. The process temperature range and catalyst type are similar to the SMR process. The hydrogen generated is a key player in our story. It can be used to synthesize ammonia and urea, addressing the fluctuating demand in the market, and all without carbon dioxide byproduct emissions. But it doesn't stop there. The other product, solid carbon, such as carbon black, graphite, carbon nanotubes, are marketable, opening up additional streams of revenue. In essence, methane pyrolysis integration creates a win-win situation. It offers an effective method to produce ammonia and urea, while also generating a marketable byproduct. But how does this solution measure up against the traditional method? To answer that, Aspen Plus software was used to simulate and compare both methods. Let's delve into the results. The simulations showed an impressive result. With a load gap of 15%, the proposed model reduced carbon dioxide emissions by up to 30%. That's a major leap towards our decarbonization goals, but it doesn't stop there. The proposed model also demonstrated lower energy consumption, a reduction of 5.8 megawatts, for a similar rate of urea production. But is this proposed model profitable? An economic analysis using the Aspen Process Economic Analyzer was conducted to answer this question. It sought to weigh the investment viability of integrating methane pyrolysis into the traditional SMR-Ammonia-Urea production process. The results were quite illuminating. The proposed model, though initially requiring a higher capital investment, proved to be profitable under the existing carbon black price and CO2 tax price framework. The profits were not just driven by the reduced CO2 emissions and lower energy consumption, but also by the valuable byproduct, carbon black. This carbon black produced from methane pyrolysis can be marketed and sold, adding a new revenue stream to the process. It's a win-win, really. Less environmental impact, more profitability. And that's the beauty of innovation, isn't it? It doesn't just solve one problem, but often brings along additional benefits, making the investment all the more worthwhile. So, the methane pyrolysis integration for the SMR-Ammonia-Urea plant not only reduces emissions, but also presents a promising option for decarbonization and a more sustainable future.